Tonight, while you try to fall asleep, something unimaginably large is drifting towards you. Not a comet, not a star, an entire galaxy. And it's already here in your sky. If you could see beyond the thin veil of atmosphere and city light, you would notice a faint smudge in the constellation of Andromeda. It looks harmless, soft, quiet, almost fragile. But that dim blur is a structure so vast that your brain refuses to hold it all at once. Inside it are hundreds of billions of stars, trillions of planets, rivers of gas stretching across distances light needs centuries to cross. And it's 2.5 million light years away. That sounds far, comfortably far. But here's the paradox. The light you see tonight left that galaxy before modern humans existed, before cities, before agriculture, before written language. The glow in your sky began its journey when early ancestors were still learning to control fire. You're not looking at Andromeda as it is. You're looking at a memory 2.5 million years old. And yet, it's coming for us. Not violently, not dramatically, slowly, inevitably. In about 4 billion years, the Milky Way and Andromeda will collide. But to understand what that truly means, to feel the scale of what is approaching, you first have to answer one question. How big is Andromeda, really? Because the answer will quietly rearrange how small you feel and how large the universe truly is. And that's where our descent begins. The first thing you must understand is that space does not behave the way size behaves on Earth. When you think big, you imagine mountains, oceans, planets. Andromeda is none of those things. It is not a solid object. It is not a glowing disk like a coin in the sky. It is a gravitational empire, officially known as Andromeda Galaxy or M31. It is the largest galaxy in our local group, the small neighborhood of galaxies gravitationally bound together, including our own Milky Way. For decades, astronomers believed Andromeda spanned about 100,000 light-years across. Similar to the Milky Way, that number alone is disorienting. 1 light-year is the distance light travels in a year, about 9.46 trillion kilometers. Multiply that by 100,000 Tao. Your calculator gives up emotionally before you do. But then something unsettling happened. Deeper observations revealed faint streams of stars stretching far beyond the visible disk, ghostly halos, tidal remnants of devoured dwarf galaxies, vast stellar outskirts. Suddenly, Andromeda wasn't 100,000 light-years wide. It might be 220,000 light-years across, more than twice the size previously imagined, and that's just the visible stars. Because galaxies have halos, enormous spheres of dark matter extending far beyond their luminous cores. Dark matter cannot be seen. It does not emit light, but its gravity sculpts motion. It holds galaxies together like invisible scaffolding. And Andromeda's dark matter halo may extend over 1 million light-years. Let that settle. The bright spiral you see in photographs is only the glowing tip of an invisible gravitational iceberg. If you could perceive dark matter, Andromeda would not appear as a disk. It would loom as a vast, translucent sphere enveloping enormous volumes of space. You would already be inside the outer whispers of its influence. And that changes everything. Now shift your perspective. Imagine shrinking the Milky Way to the size of a dinner plate. Andromeda would be slightly larger. Now place those two plates 2.5 million light-years apart, roughly 25 plate widths at that scale. They are not static. They are moving toward each other at about 110 kilometers per second. Every second, Andromeda drifts 110 kilometers closer to you. You don't feel it. You don't hear it. But it's happening. The universe is quiet, but it is never still. To truly grasp Andromeda's size, consider this. If you traveled at the speed of light, it would take you 220,000 dials and zeros to cross its visible diameter. Not around it, across it. Civilizations could rise and fall on Earth while you were still crossing one edge to the other. And that's just one galaxy. Inside Andromeda are possibly 1 trillion stars, significantly more than the Milky Way's estimated 400 billion. Each star could host planets, moons, oceans, skies. Entire histories may be unfolding there, or have already ended. When you look at Andromeda, you are not just seeing size. You are seeing time compressed into light, and yet something else makes Andromeda even more extraordinary. Its central black hole. At its core lies a supermassive black hole about 100 million times the mass of our Sun, far more massive than Sagittarius A*, the 4 million solar mass black hole at the center of the Milky Way. The gravitational choreography inside Andromeda is more intense, more ancient, more layered, and it has cannibalized smaller galaxies to become what it is today. Look closely at deep images and you'll see stellar streams, long arcs of stars torn from swallowed companions. Andromeda grew by consuming others. Size in the universe is often built on cosmic violence, but here is the conceptual shift. Even though Andromeda is larger in stellar count and halo mass, the Milky Way may not be dramatically smaller in total mass when dark matter is included. Some recent studies suggest the two galaxies may be closer in mass than once thought. So the coming collision may not be a small galaxy being absorbed by a giant. It may be two titans merging. 4 billion years from now, the night sky will not look the same. As Andromeda approaches, it will grow larger in our sky over hundreds of millions of years. Spiral arms will stretch across the heavens. The stars within each galaxy will mostly pass by each other without direct collision. Space is too vast for frequent star-to-star impacts. But gravity will reshape everything. Stars will be flung into new orbits. Gas clouds will compress and ignite furious waves of star formation. The two central black holes will spiral toward one another and merge in a gravitational dance that shakes space-time itself. And the result will likely be a new galaxy, sometimes nicknamed Milkomeda. Bigger, elliptical, transformed. The universe does not preserve form. It evolves scale. Now pause, because something subtle is happening to your perception. You began with a faint smudge in the sky. Now you're imagining million light-year halos and trillion star systems colliding across cosmic time. And yet, from Earth, Andromeda looks small, a dim blur. That contrast is the real lesson. Size in the universe is not about what you see. It's about what you cannot. And this is where sleep science meets cosmic scale. When you close your eyes tonight, your brain will attempt to simulate space, to imagine 220,000 light years, to hold 1 trillion suns in mental architecture. But your neural hardware evolved to track predators across savannas. It did not evolve to process galaxies. So what happens? Your mind compresses the incomprehensible into symbols. A swirl, a disk, a glowing shape. You reduce Andromeda to something manageable. But reality remains vast beyond symbol, and that psychological gap between symbol and scale is where awe lives. Awe is what happens when cognitive limits collide with immensity. Studies show that experiencing vastness, whether mountains, oceans, or galaxies, quiets the ego. It shrinks self-focus. It expands perception of time. Thinking about Andromeda literally changes your brain's sense of scale. It slows your thoughts. It stretches your sense of now. And perhaps that is why contemplating galaxies helps you sleep. Because when you understand how large Andromeda truly is, your worries, deadlines, arguments, tomorrow's noise lose proportion. They still matter, but they do not dominate. You exist in a universe where galaxies drift and merge over billions of years. Your anxieties are brief sparks in a cosmic ocean. And yet, you are made of the same elements forged in stars, perhaps even in galaxies like Andromeda long ago. There is no strict boundary between you and that distant system. The iron in your blood was born in stellar cores. The calcium in your bones was forged in exploding suns. You are local matter rearranged. So when you ask how big Andromeda is, you are also asking how small you are. And the answer is paradoxical. You are astronomically tiny and cosmically connected. The faint smudge in the sky is not just a distant object. It is part of a gravitational web you inhabit. You are already falling toward it, slowly, inevitably. And that motion, silent, invisible, unstoppable, continues even as you drift towards sleep. But there is one more layer, because Andromeda's size is not fixed. It is expanding through accretion, through dark matter influence, through the stretching fabric of the universe itself. And beyond it lie billions more galaxies, each larger than comprehension, each receding into darkness. If Andromeda feels large, now imagine zooming out. See the local group as a tiny knot of galaxies. Zoom further clusters, further superclusters, further the cosmic web, a filamentary structure stretching across hundreds of millions of light years. At that scale, Andromeda is a speck. At that scale, the Milky Way is a whisper. At that scale, you are less than dust. But here is the quiet shock. Despite all of this size, all of this incomprehensible distance, the light from Andromeda reaches your eyes. The universe is vast, but it is not disconnected. And tonight, as you lie beneath the sky, that ancient light touches you. 2.5 million years of travel ending on your retina. Size is not just measurement, it is relationship. And Andromeda, impossibly large, impossibly distant, is already part of your story. Because in 4 billion years, when galaxies merge and reshape the night, some distant civilization, perhaps orbiting a star formed in that collision, may look back across space and ask, how big was the galaxy that came before? And they will be asking about us. So close your eyes. Picture a spiral stretching 220,000 light-years wide. Picture invisible halos extending 1,000,000 light-years outward. Picture trillions of worlds circling silent suns. And understand this: the universe is not just large. It is larger than your capacity to hold it. And yet you try. And in that attempt, in that reaching beyond mental limits, something extraordinary happens. You expand, just a little, enough to feel both small and infinite at the same time. And as sleep arrives, the galaxy keeps moving, closer, always closer, not as a threat, but as a reminder that reality is far bigger than fear, and far more beautiful than comprehension. And tomorrow night, if you look carefully at the sky, that faint smudge will still be there, unchanged to your eyes, but in truth, 110 kilometers closer. The first time humans realized Andromeda was not a nebula, not a cloud inside our own galaxy, but an entirely separate island universe. The scale of existence shattered overnight. In the early 20th century, astronomers argued fiercely about what those faint spiral smudges truly were. Some believed they were small, nearby gas clouds inside the Milky Way. Others suspected something far more radical, that they were galaxies of their own. The debate climaxed in 1920 during the famous Great Debate between Harlow Shapley and Heber Curtis. Shapley argued the Milky Way was the entire universe. Curtis argued the spirals were distant galaxies. Imagine standing at the edge of human knowledge and being told the universe might be billions of times larger than you thought. Then came the breakthrough. In 1923, Edwin Hubble observed a Cepheid variable star inside Andromeda using the Hooker telescope at Mount Wilson Observatory. Cepheid stars pulse in brightness at predictable rates. Measure the pulse, calculate the intrinsic luminosity, compare to apparent brightness, and you can determine distance. Hubble did the math. Andromeda was not inside the Milky Way. It was 2.5 million light-years away. The universe expanded overnight. And with that expansion came a new question: if Andromeda is that far away and still visible to the naked eye, how large must it actually be? Here's the quiet shock. From Earth, Andromeda spans about 3 degrees across the sky, 6 times the apparent width of the full moon. You just can't see most of it because your eyes are not sensitive enough. If human vision could detect its faint outer halo, Andromeda would dominate the night like a ghostly oval stretching across a huge swath of sky. The moon looks large because it is close. Andromeda looks small because it is distant. But angular size does not equal physical size. Andromeda's disk is roughly 220,000 light-years across, but its stellar halo extends far beyond that. And its dark matter halo stretches perhaps 1,000,000 light-years outward. To feel this scale, you must compress it into something graspable. Shrink Andromeda down so its visible disk is the size of North America. Now imagine its dark matter halo extending across the entire Pacific Ocean, reaching nearly to Asia. That is the gravitational footprint of a single galaxy, and we are on a collision course with it. But before we leap into the future, we need to understand something deeper. Size in astronomy is rarely about edges. Galaxies do not have clean boundaries like planets. There is no wall where Andromeda ends. Instead, density fades gradually, stars become sparse, gas thins, dark matter dominates. The outer halo is less a border and more a whisper, and that whisper may already be brushing against the Milky Way's own halo. Some studies suggest that the dark matter halos of Andromeda and the Milky Way may already be interacting, subtly overlapping across intergalactic space. If that's true, then the collision has already begun. Not in dramatic flashes, not in fire, but in gravity. Invisible tendrils reaching across millions of light-years. Now zoom inward. Inside Andromeda's bright spiral arms, stars orbit the galactic center at staggering speeds, hundreds of kilometers per second. If gravity were only produced by visible matter, those stars should fly apart. They don't. Dark matter holds them in. This is how astronomers infer the galaxy's total mass by measuring rotation curves. The outer stars move too fast for the visible mass alone, and the conclusion is astonishing. Andromeda's total mass may be around 1 to 2 trillion times the mass of the Sun. Trillion. You say the word, but your brain does not attach meaning to it. 1 trillion seconds is over 31,000 years. $1 trillion stacked in $100 bills would reach into space. 1 trillion stars each with planetary systems implies planetary diversity beyond imagination. And yet Andromeda may hold even more. Because galaxies grow by devouring smaller ones. Andromeda has consumed many dwarf galaxies over billions of years. Their remnants are still visible as faint stellar streams arcing through its halo, fossil evidence of past mergers. You're not looking at a static spiral. You're looking at a layered archive of cosmic violence. Every stream of stars tells a story of gravitational capture. Every asymmetry in its disk hints at ancient collisions. And that means something profound. The size of Andromeda is not just physical, it is historical. Its mass is accumulated memory. And when it merges with the Milky Way, our galaxy's history will merge with it. Two archives blending into one. Now shift perspective again. Imagine you are standing on a hypothetical planet orbiting a star near Andromeda's outer edge. The core would blaze in the distance, a dense bulge of golden light packed with billions of stars. Night would never be truly dark. The sky would be textured with star clouds so thick they cast faint shadows. Compared to Earth's relatively sparse stellar neighborhood, Andromeda's inner regions would feel overwhelmingly luminous. But move outward toward its halo and space becomes lonelier. Stars thin out, distances widen, silence deepens. The same galaxy contains both overcrowded brilliance and vast emptiness. Scale is not uniform, it breathes. Now let's stretch your perception further. If Andromeda were placed at the distance of the Moon, its disk would fill the sky from horizon to horizon, a swirling storm of light dominating everything. You would not see black sky, you would see a galaxy. This thought experiment reveals something subtle. Andromeda appears small only because of distance. Remove distance and its immensity overwhelms. Distance is what makes the universe psychologically survivable. Without it, scale would crush us. And that leads to a deeper paradox. The larger the universe becomes in our understanding, the more fragile Earth feels. Because in a galaxy 220,000 light-years wide, Earth occupies no privileged location. We orbit a star in the outer suburbs of a spiral arm. We are not central. We are not special in position. Yet consciousness arose here. Atoms forged in ancient stellar cores organized into neural networks capable of contemplating galactic dimensions. This is the most unlikely symmetry. A universe vast beyond comprehension and a species small enough to be invisible within it yet able to measure it. And as you lie in the dark thinking about Andromeda, neurons fire in patterns that map millions of light years. Your brain, 3 pounds of biological matter, simulates trillion star systems. Scale collapses into thought. That is extraordinary. But there is still something we have not addressed: motion. Andromeda is not merely large, it is approaching. Spectroscopic measurements reveal a blue shift, its light slightly compressed, indicating motion toward us. Most galaxies in the universe are receding due to cosmic expansion. Andromeda is one of the few large galaxies moving closer. Why? Because on small enough scales, gravity overpowers expansion. The local group is gravitationally bound. Cosmic expansion stretches space across vast intergalactic voids, but here, gravity wins. This is the battlefield between two forces: expansion and attraction. Andromeda and the Milky Way are locked in a slow gravitational embrace. Over billions of years they will spiral inward. Their outer halos will tangle first. Then tidal forces will stretch spiral arms into long luminous arcs. Then the disks will interpenetrate. Star formation will surge as gas clouds collide. But here's the surprising part. Individual stars will almost never collide directly. Despite containing hundreds of billions of stars, galaxies are mostly empty space. If the Sun were the size of a marble, the nearest star would be hundreds of kilometers away. Galactic collisions are graceful, slow, more like two flocks of birds passing through each other than two solid objects smashing. And yet the overall structure will change completely. Spiral patterns will distort. Central black holes will merge, releasing gravitational waves rippling across space-time. The final structure may be an elliptical galaxy, smoother, rounder, less defined. The night sky from Earth, if Earth still exists, would transform over millions of years. Brighter, more chaotic, unrecognizable, and somewhere within that new galaxy, new stars will ignite. New planetary systems will form from the mixed debris of two ancestral galaxies, future worlds built from the dust of ours. So how big is Andromeda really? It is large enough to contain 1 trillion suns, large enough to stretch 220,000 light-years across in visible light, large enough for its invisible halo to span nearly 1 million light-years, large enough to reshape our galaxy, large enough to alter the sky of the far future. But its true immensity is not just physical. It is temporal, because when you look at Andromeda, you are looking across 2.5 million years. You are peering into deep time. And when it merges with us in 4 billion years, the resulting galaxy will carry forward both histories. Size becomes duration. Mass becomes memory. Distance becomes destiny. And here, as sleep begins to pull at the edges of your awareness, consider this. You are alive in the brief interval between galaxies approaching and galaxies colliding. You exist during a cosmic pause long before the merger, long after Andromeda's light began traveling. A temporary window of clarity. You are not witnessing the collision. You are witnessing anticipation. And anticipation has its own quiet power. Because somewhere out there, across that 2.5 million light-year gulf, another civilization, if it exists, may be looking at the Milky Way right now. They see our galaxy as it was 2.5 million years ago. Primitive, star-filled, unaware. They do not see you. Not yet. Their light and ours cross silently in intergalactic space. Two enormous systems, each carrying trillions of stories, drifting closer every second. And as gravity tightens its hold, as halos overlap and dark matter whispers across the void, the real question shifts. Not just how big is Andromeda, but how small is the moment you occupy within this vast unfolding. Because scale does not just dwarf you, it frames you. And in the next movement of our journey, we will step even further back beyond Andromeda, beyond the local group, and confront a structure so immense that both galaxies become mere threads in something unimaginably larger. And when that perspective arrives, even Andromeda will feel small. Now pull back again, further, until the Andromeda Galaxy, that 220,000 light-year spiral with 1 trillion suns and 1 million light-year halo, begins to shrink. At first it still feels immense, a titan drifting through blackness, but keeps zooming out. The Milky Way and Andromeda become two luminous disks suspended in a shared gravitational envelope, the local group, a small collection of more than 50 galaxies bound together by invisible mass. Dwarf galaxies orbit like moths around lanterns. Dark matter weaves through all of it. From this vantage point, the coming collision is no longer dramatic. It is ordinary. Galaxies merge all the time. Zoom out further. The local group is not isolated. It is falling toward a larger structure, the Virgo cluster, a swarm of thousands of galaxies bound in a common gravitational well. Each one vast, each one filled with billions of stars. And beyond Virgo lies something even larger, Ponder. The Laniakea supercluster, a region spanning roughly 500 million light-years, containing around 100,000 galaxies, all flowing along filaments toward a gravitational basin called the Great Attractor. Now pause. Remember how overwhelming Andromeda felt? It is now a speck, a single luminous cell in a cosmic organism so large it takes light 500 million years to cross it. And even Laniakea is not the whole story. On the grandest scales we can map, the universe resembles a web, vast filaments of galaxies stretching across billions of light-years, separated by immense voids. This is the cosmic web. It looks almost biological, like neural tissue, like the branching structure of the brain contemplating it. And here is the quiet symmetry. The same physical laws that govern gravity sculpt both galaxies and neurons. Small and large mirror each other. But something unsettling emerges when you stand at this scale. The universe is expanding, not just moving, expanding. Distant galaxies are receding from us, carried by the stretching fabric of space-time itself. This expansion was first measured by Edwin Hubble when he discovered that distant galaxies are redshifted, their light stretched toward longer wavelengths. The farther away a galaxy is, the faster it recedes. Space itself is growing. That means there are galaxies so distant that their light will never reach us. Ever. Beyond a certain horizon, expansion outpaces light. There are parts of the universe permanently unreachable, permanently unknowable, even if you traveled forever. Even at light speed. This is where size becomes existential, because when you ask how big Andromeda is, you are touching a larger question. How big is reality? The observable universe spans about 93 billion light-years in diameter. Not because it is 93 billion years old, it's about 13.8 billion years old, but because space has expanded during the time light has traveled. 93 billion light-years, your brain cannot visualize it. It can barely hold the number. If Andromeda's size stretched your imagination, the observable universe obliterates it. And yet, every atom in your body originated in stars inside galaxies like Andromeda. Heavy elements, carbon, oxygen, iron, were forged in stellar cores and supernova explosions billions of years ago. You are not separate from cosmic scale, you are its byproduct. This is the deepest inversion of all. The universe becomes large enough to make you feel insignificant. Then physics reveals you are made from it, and significance returns transformed. Now consider time. If the Milky Way and Andromeda merge in 4 billion years, Earth may not survive unchanged. The sun will be brighter by then. Oceans may have evaporated, complex life may be gone. Human civilization as you know it occupies less than a blink compared to galactic timescales. The entire span of recorded history is about 5,000 years. Andromeda's light takes 2.5 million years to arrive. The merger will take billions. Your lifetime, perhaps 80 years, is less than a rounding error in galactic evolution. But here is the counterweight. Scale does not invalidate meaning. It reframes it. Because meaning is not measured in light years. It is measured in experience. When you lie awake at night and imagine Andromeda's vast disk, when your mind stretches beyond instinct and survival and reaches into deep time, you are performing an act. No galaxy can performing an act. No galaxy can perform. You are becoming aware of scale, and awareness is rare. As far as we know, consciousness may be uncommon in the universe. Stars burn without reflection. Black holes curve space-time without curiosity. Galaxies merge without wonder. But you, a temporary arrangement of atoms on a small rocky planet, can look up and calculate the mass of 1 trillion suns. You can measure blue shift and predict collision timelines. You can map dark matter halos you cannot see. You can ask, how big is it? And you can understand the answer. That is astonishing. Now return to Andromeda one final time. Imagine it approaching over billions of years. At first it is a faint blur, then brighter. Then its spiral arms become visible to the naked eye. Then it stretches across the sky like a luminous river. Then stars begin to shift position subtly over generations. Then the sky transforms into something entirely alien. And somewhere during that long transformation, new worlds ignite. New civilizations may arise under skies crowded with merging galaxies. To them, the collision will not be catastrophe, it will be history. They will inherit a galaxy born from two, and they may ask the same question you asked tonight. How big is the galaxy we call home? Perhaps by then they will have mapped its full halo, measured its merged black hole, charted every stellar stream, and even then they will confront the same boundary, because no matter how large the galaxy, it exists within something larger, and that within something larger, endlessly. This is the final quiet realization. Size has no ultimate ceiling in cosmology. Every structure sits inside a greater context. Every boundary dissolves at a wider scale. And your mind, though limited, keeps reaching. Now let the paradox settle. Andromeda is unimaginably large, hundreds of thousands of light years across, 1 trillion stars deep, wrapped in a dark halo stretching toward intergalactic space. It is moving toward us. It will reshape our galaxy. It dwarfs any human concept of distance, and yet its ancient light lands softly on your retina. Photons that began their journey before human civilization now end their voyage inside your eye. The vast becomes intimate, the distant becomes personal, and here, at the edge of sleep, that may be the most important truth. You are small, but not detached. You are brief, but not irrelevant. You are made of the same processes that built Andromeda. When you contemplate its size, the universe becomes aware of itself through you, not because you are central, but because you are conscious. So tonight, as gravity continues its slow, silent pull between galaxies, as dark matter halos overlap invisibly across millions of light years, as the cosmic web stretches across billions of light years of expanding space, you rest on a small planet orbiting an ordinary star in the outer arm of the Milky Way, drifting toward a trillion-star neighbor, carried by a universe so vast it erases ego and so coherent it creates minds capable of measuring it. How big is the Andromeda Galaxy really? Big enough to humble you, big enough to reshape the sky, big enough to remind you that scale is relative but connection is real. And in the dark, as your thoughts slow and your breathing steadies, that faint smudge in the constellation of Andromeda remains, ancient light, approaching gravity. A galaxy wide enough to take 220,000 years to cross, and somehow close enough to touch you tonight.